All right, welcome everyone to today's Lunch and Learn. I'm gonna go ahead and get started. Hopefully we'll get some more people filtering in. So my name is Dylan Agnes and I work for the Integrated Design Lab. We are a researching and consulting firm. We're currently 6 strong. Jubin just left us for a job on the East Coast. But I believe we're close to hiring a replacement, the last I heard. So this lecture is sponsored by the Idaho Power Company. They sponsor a couple of the programs that we do, one of them being Technical Design Assistance. Technical Design Assistance is broken into 3 phases, generally outlined by the scope of work and the hours for the project. So less than $2,000 of our time would be a phase 1, all the way up to phase 3, which is greater than $4,000. However, phase 3 does require a cost share with the owner, but 75% is covered by Idaho Power. To qualify for technical design assistance, the project must be going above code requirement. And so you can find more information about that at our website, or you can email Damon Woods. Another program we have is the Energy Resource Library. We have over 800 diagnostic building analysis tools, ranging anywhere from thermal cameras, light meters, flow meters, various data loggers. We do have a contactless pickup and drop-off system. So if you're interested in that, please visit our website, idlboise.com/about-ERL. And lastly, please check out the commercial and industrial energy efficiency programs under Idaho Power. Please go to idahopower.com/business for more details. All right, with that out of the way, we're going to get into today's lecture. We're going to talk about the future of lighting controls. I want to apologize up front. There are a lot of acronyms in today's lecture. So just keep that in mind going forward. I'll try to define them as best I can, but if you have any questions at any point, feel free to unmute yourself, interrupt me, or you can post it in the chat and I'll get to it when I see it. So we're going to cover the Internet of Things, the Internet of Lights, Power over Ethernet. We're going to follow the light, which is a fancy way of talking about the lighting chain value and kind of the impact these upcoming technologies and control strategies will have on the industry. We'll cover the pros and cons of the Internet of Lighting, as well as when and where for recommended uses, and then we'll conclude. So the Internet of Things, you're not aware, is a collection of computing devices embedded in everyday objects that allow them to send and receive data. So it can be considered a sensor network in which they're connected to the internet, and so those things kind of become end nodes. But for our purposes, the things that we consider are going to be thermostats, occupancy sensors, photocells, mobile devices, plug loads, etc. So these things can be connected to create a network. In our case, a sensor network is what we're interested in, that can be used to solve energy management in buildings and be used as the basis for future planning and decision making in buildings. The IoT, Internet of Things, is triggering changes in the lighting industry from a traditional closed proprietary systems to more flexible, interoperable, and systems-oriented, or service-oriented systems, sorry. So here's kind of a visual image, kind of what the Internet of Things touches, and we're just going to talk about a narrow slice of it that applies to our industry. And so what I mean by that is we're going to talk about control strategies. So is it predefined, intelligent, or is it remote on-demand basis? Devices, are they network? Are we talking about lighting sources, additional sensors, as well as connectivity? How are we connecting those, whether it's through wireless infrastructure or wired infrastructure? What type of infrastructure does that entail? as well as the more complex side of it, dealing with algorithms for human behavior and comfort. So this is in regard to circadian cycles, color perception, as well as just human behavioral preference. Just what is your preference for, do you like to work in a cave or do you like to work with the sun, shining on your face? So for our sense then, it's not so much the Internet of Things as it is the Internet of Lighting. So the Internet of Lighting is an indoor lighting system that consists of multiple luminaires with IP addresses. Sensors and controllers are to be considered. The sensors provide information for controlling artificial lighting systems and additionally serve as a data source for other building systems and services. So what that's useful for is integrating intelligent technology for optimizing building energy systems. Intelligent systems of unified planning, design, equipment, and systems to achieve resource sharing with information exchange. So kind of what this is knocking at the door at is allowing a lot of different systems that can be controlled by a building automation system to kind of start to talk to each other and share information. So advanced services can serve as a hub for optical communication that allows the coexistence with traditional network infrastructure such as Wi-Fi or Bluetooth. Lighting systems are evolving to support different wired and wireless communication interfaces compatible with the IoT ecosystem. Smart lighting should be conceived as an adaptable lighting system with the objective to improve visual or occupant comfort first, then energy efficiency. We'll get into that later. So here's kind of a diagram, what a typical network infrastructure would look like. And, a typical office building that has a building automation system, has sensors, monitoring its power and whatnot. What IOL does is it becomes this orange line where it's going to give you a way to communicate from top to bottom through everything to the cloud, where the building automation controller or facilities manager, what have you, can access that information and make real-time changes to the programming. So the overall goal is to join drivers with sensors so that the control algorithms and wireless communications are able to deploy scalable lighting solutions to work autonomously in the IoT ecosystem that we're kind of starting to see in our buildings. Some key takeaways is that it eliminates costs and failure points from LEDs, embeds controls in the power line, simplifies and reduces wiring costs, and acts as a convergence points for building system controls. So a technology that's really up and coming, and Europe and China kind of ahead of us in this, but in America, we're just now starting to see and adopt Luminaire Level Lighting Controls, LLLCs. These fixtures have sensors and controls within the individual fixtures, so they're embedded during the manufacturing process, and they can be controlled remotely or on a case-by-case basis. This remote control allows users to adjust the programming criteria or illumination levels without replacing the fixture or any actual hardware, because you're reprogramming. So I kind of like to break that down into zoning area-based approach versus the fixture-based approach. So the zoning-based approach is what you typically have, where you have 2 to 3 occupancy sensors in an open office area, and those are assigned into groups, and those are controlling the lights. So that's an area-based approach. And so you can think about it in terms of resolution. So you have 3 sensors in that area. So while you do have an idea of what's going on, it's a very limited amount of data that you're viewing. So you're about 72 dpi. You can tell what the picture is, but it's kind of fuzzy. You're not really sure, but you can kind of, guesstimate. The fixture-based approach is the opposite, where you imagine every light in that open office area has an occupancy sensors or a photo cell or an air temperature, etc. And so that increases the amount of data we're receiving in a space. And so we're getting a much more clearer image. So if each of those light fixtures had a thermal camera or an air temperature sensor, then we could get a gradient heat map of what the room temperature is like. Versus if we went to zoning area based, it's a lot. We don't have that fine grain. It's kind of more just area hard lines. So IEC defines LLC as a system in which Luminaire's features embedded intelligence, occupancy sensors, or occupancy and light sensors, wireless networking capability, where local override switching capability is required. So this is kind of this is relatively new. This is in 2018. And so like I said, we're not, the industry really likes this. Regulators aren't really sure entirely what to use it for, as are a lot of the actual customers, because it can do quite a bit. So that's something to keep in mind, is that there are a lot of options, and you don't want to get bogged down by having too many options or too many variables. So this is kind of what I'm talking about. That Luminaire Level Lighting Controls can touch quite a bit. Wayfinding, asset tracking, security, all the way to air quality and temperature, networking, and Wi-Fi, Bluetooth connectivity. So Hayes' law predicts the luminous efficacy will rise every decade, and in the future, the cost per lumen will continue to decrease. Now, that's very important as far as we're going to talk about later in just a moment for wiring infrastructure. Luminaires that are specifically rated to autonomous sensing capabilities extend the IoT connectivity, scalability, and interoperability features in different segments, as well as also enhancing communication for smart lighting systems. Connecting the hardware to software with network capacity to expand functionality and efficiency leads to a significantly more advantageous when the hardware is packaged together with a network capability built in. So that means basically Luminaire Lighting, as I was telling you earlier, the fixtures have the sensors embedded already when they're being manufactured. That's what I'm talking about. And so with that scalability of efficiency for LEDs, kind of leads us to power over Ethernet. So power over Ethernet is not a new technology. It's not emerging or upcoming. It's been around for at least a decade. But however, I believe PoE is the next step to fully realize the potential of IOL, as it allows highly efficient lighting, as well as sophisticated digital control and communication with equipment. You can simultaneously transmit data and DC power. This reduces the power consumption, infrastructure maintenance, as well as providing a real-time feedback loop. It eliminates additional electrical wiring needed for systems. This is really good for reducing cost and labor reductions, particularly in retrofits. It kind of gets a little messy with new buildings, because you have to change when you're installing that. We can get into that later. Streamline or pipeline process for commissioning and future calibrations. How can a network, and so basically all this, kind of seems too good to be true. So pose the question, how can a network infrastructure generate or carry enough load to power the lighting or control system infrastructure? Well, one of the ways, kind of the code, the NEC, I'm going to be honest with you, I don't entirely understand the electrical engineering code. It's just not my specialty. But basically, they've slowly been improving PoE standard and operability. And with LEDs being as efficient as they are, they actually come in and qualify as under a technicality as a recipient to use this infrastructure. However, what we commonly see Power Ethernet being used for is more security, so cameras, phones, alarm systems. Then we kind of see it evolve even further. Like I know in the water center where I work, I no longer plug my desktop into an actual Ethernet port. I plug it into my phone, and my phone is plugged into the Ethernet port, so my phone is acting as my router. So we start to see that for laptops, computers, video conferencing, televisions, etc. And so we keep going, and the latest development is having PoE cords bundled together. I believe it's Cat5B, B, and then FE are the two types. And those get you up to 90 to 95 watts transmission over the line. And that's within a safer range than what we're typically used to installing into our buildings. And because of LEDs, they can operate on that. So most lighting systems prepared for the IoT ecosystem include a power conversion stage with a constant current LED driver, several LEDs organized in arrays, and the incursion of sensors and communication interface. However, PoE kind of changes that. It offers an advantage over typical lighting infrastructure, which is that instead of stepping the power down at each and every fixture, you're doing it on one robust power supply. So you can kind of think of that as doing it upstream. So before it all happens, before you get to each light. So this allows for an uninterrupted power supply. A UPoE network switch that detects whether to send power to connected to devices, can assign a unique IP address to each device. It increases design flexibility as anyone can relocate a fixture without the expertise of an electrician. So basically, you kind of think about if you wanted to unplug your phone and move it to a different desk and plug it in, you don't necessarily have to reprogram that phone because it's been programmed for you. So when you plug it in, it gives the network its profile information. And it's like, oh, this is Dylan's phone. He moved from one port to another, but we know it's him and he uses the network. We can let him connect. This is the same thing. Basically, if you have Power over Ethernet infrastructure installed, you won't be able to get that kind of flexibility with a retrofit because there's still going to be that existing infrastructure of electrical wiring that you still have to deal with. But it will make it a lot easier. The other thing Power Ethernet does is that it allows LEDs to evolve again. So with higher power levels, 95 watts from the IEE 802, more equipment is eligible to use PoE, thereby eliminating the need for many AC to DC converter for commercial equipment. So one of the biggest degradations in the lifespan of LED is heat. Most of the heat in the LED fixture actually comes from the power conversion. So if we remove that, LED's lifespans go a lot further, and we can actually change how we design the actual fixture itself, because we're no longer having to account for that space as well as the maintenance over time to keep the longevity of the fixture from degrading from the heat. So some things to consider for Power over Ethernet is distance. It's limited. Heat and insulation with concerns towards degradation. So how long will that infrastructure last before it has to be replaced with a new wiring, as well as the NEC's code making panel. So distance, PoE can transmit up to 100 meters from the switch or hub, regardless of where the power is injected. The limitation is not the power, it's the Ethernet cabling standards that limit the total length of cabling to 100 meters. However, there are extenders available. Those can lengthen that span up to 4,000 feet. And so that kind of gets to what I was saying about this was not intended for a lighting system. That's not what the developers, the regulators see it as. So the high potential, so this makes it a high potential and perfect candidate for deploying smart grids in buildings. Heat and insulation. So as typical in building power distribution cables, the major concerns are heat buildup, as well as the insulation's long-term integrity to avoid electrical shocks or ground faults. This is being considered and still being evaluated for the bundle PoE cables I mentioned. The latest development is that it allows for 90-watt transmissions. Additional consideration is related to maintaining the integrity of the data and how this new proposed use for power of Ethernet luminaires. So the NEC's code-making panel don't generally consider a lighting power source as information technology equipment. They don't think you're going to be sending a signal or downloading something from your lighting fixture. Or, as they define it, the purpose of exchanging information. So while code authorities retain a great deal of discretion, when installers are explicitly permitted in the text of the code, it's basically written in that they've kind of acknowledged this existence for ILL, but they're not entirely sure what to do with it. So they give discretion to the actual evaluators when they go out into the field and certify, because they basically explain to them and provide documentation explaining what they're doing. And yes, no, I know this isn't what you thought, but technically there is data being exchanged, and the light is now an information technology equipment, as well as to being a luminaire. And so what that gets into the big picture of smart grids. Smart grid is an electrical grid which includes a variety of option and energy measures, including smart meters, smart appliances, renewable energy resources, and energy efficient resources. So this is kind of an image to kind of give you, that's kind of what we think of the smart grid as. However, with this, we're kind of starting to step into additional grids, such as the micro or nano grid. And so what that basically means, the smart grid is the built environment. And then we kind of step down into the building, to the floor level, to the room, to individual workstation, to the actual user themselves providing us data. And so what that looks like with what I've been talking about, the macro smart grid is kind of connecting the built environment smart grid to individual buildings, not just the overall civic infrastructure that exists. LLLCs goes from the building down to the workstation. Not so much the user at the moment, but it is knocking on that door of doing that. When it does do that, it kind of transitions to the Internet of Lighting, which goes from the building all the way down to the user. And so you're going to see that IOL can kind of connect the micro smart grids, which is just kind of our individual behavior patterns, tendencies, data, metadata that we give off through using our smart devices, all the way up to the macro smart grid, which is the building. How does the building performing and operating? How is that building operating in regards to other buildings that are similar of its characteristics and its climate or a city? So a brief summary, the Internet of Things extends the Internet protocol communication to billions of resource-constrained endpoints or things. The Internet of Lighting, advanced services serving as a hub for optical communication that allows coexistence with traditional network infrastructure such as Wi-Fi or Bluetooth. PoE, power over Ethernet, redefines the infrastructure needed to power and control equipment, as well as how we distribute power in a building. So how is the lighting industry affected by these new technologies and strategies? Well, IoT enables seamless communication, contextual services, and data sharing between things, and is bringing radical changes in several industries by converging multitudes of vertical markets. The transformation from traditional lighting, compact fluorescence, to LEDs makes the transition from light point to IP end nodes. is kind of what you can correlate those two as. So before I go on, does anyone have any questions about what I've talked about so far? Okay, we'll move on. So kind of the way the lighting value chain currently works is broken into the creation and the use phase. The creation phase being the supplier, installer, commissioner, the actual designer, the contracting, contractor, all kind of overseen by the building architect. The actual use and maintenance of the system is transferred over to either the owner, facility manager, tenant, or inhabitant. And with the Internet of Lighting, we can actually include IT management in that now. So a major challenge to moving the lighting industry towards IoT is that certain tasks, i.e. installation, commissioning activities, and maintenance will be more automated and require significantly less time to complete. Therefore, individuals employed in this sector of the lighting industry will be heavily impacted through replacement, reduction in workforce capacity needed, and additional skills required. So what that kind of gets into is that commissioning a building can no longer, you no longer have to actually physically visit the building to do it. You can remote into the system off-site and have the system run the diagnostics and provide you a data and a report on how the system was installed, how it's operating, what its current levels, what standards it's adhering to, what control strategies it's using, etc. And furthermore, you could actually get through probably more commissioning jobs than you would if you had to go physically visit the site. In addition, additional skills required kind of refers to what I mentioned earlier about IT management. So if your lighting infrastructure is now also a network, and the power's fine, but the network goes down either through poor data management or an influx of data, cyber attack, etc. Who do you call to fix the light? Do you call typical maintenance? Do you call the electrician, or do you call IT to come reset the network and do some protocol testing? So it can get a little confusing. But the most thing to know about is the thing that is changing the most in the value change is the proprietary evaluation. So what I mean is a closed API versus open API. That's applicable programming interface. So basically, that can be broken down to is, are you allowed to edit and change the software? So currently, we're more of a closed API industry. Company keeps development in-house, allows development team for the company to use existing assets to make applications, provides the API publisher with a higher degree of control over the types of apps that are developed, and the different functions that it can perform. However, if the person designing that software application did not intend for you to do something, then you won't be able to do it. You can't go and make your own button or your own drop-down option to select. Whereas the open API, it does that. Hopefully, I more subscribe to the camp of open API. That's what I prefer. An open API is one that has been developed with the intent of it being accessible to outside developers. The main benefit to this is that it can stimulate innovation and increase the amount of development without the API publisher having to invest heavily in the process. The company may have their own in-house team and contractors that will develop applications using the interface, but the main idea is to get developers from the outside working on the application for the environment that the company has created. So you can kind of think of that as, for those of you who heard me talk about Radiance versus Insight. Radiance is an open API. You can make your own scripts, standards to run them on. You can make your own buttons, change the graphical input, how things are rendered, etc. with something like Autodesk Insight, sometimes it's really nice because if you say, hey, I'm applying for LEED accreditation and I need to run a daylight simulation that is going to meet that standard, they have a drop-down option menu. And you can click that, and all the variables and inputs are predefined, and you don't get to change them. Sometimes that's great. Sometimes it's not. So it's kind of what you're going to be using the intent for, the longevity of it. So how long can the industry hold out? Currently, the standards are BACnet, KNK, and DALI. They're the most prevailing use for lighting controls. However, there are newcomers into the industry, not necessarily new themselves as companies, but new to this industry themselves. One being Qualcomm. They make, you probably know of them through their data chips that they make for phones. There's other smart devices, laptops, tablets, etc. Those type of companies that focus on that type of are interested in seeing Luminaire level lighting controls or the Internet of Lighting come to fruition, because that means they have more customers to sell to and they have more data to work with. So there are a couple of different ones. The one in America is the All-Seen Alliance. It's a collaboration of companies, the big one being Qualcomm. Then you have the Open Interconnect Consortium. That's more of a Linux-based, very open API. I should say the All-Seen Alliance is a closed API. The OIC is open, and then the last one, OpenAIS, that is European. So they're definitely for trying to get not just their lighting systems online to talk to themselves and other objects from the Internet of Things, as well as the building management systems they currently use and all those standards. So here's kind of, I'm not going to go through and read all this for you, but if you did want to know what those standards were defined as and kind of what they're used for, there it is. So how do we create the IOL standard? It's going to be IP-based using a general communication protocol such as IP. The end-to-end connectivity property of IP provides basic interoperability where devices can communicate without protocol translation, and data can be shared across many systems. It's going to be open, or it should be open and reusable. A closed standard will create doubts by potential users on the availability, cost, and freedom of use. So say you install Internet of Lighting in your building. I mean, it's going great. It's operating nice. 6 years go by, and the actual original company that made that lighting system goes under, and they're no longer there to support the software that you use. It's kind of out of luck, and you kind of got to switch now. So that's why I definitely, my opinion, the open API is more suited for the longevity and flexibility that this technology is trying to offer than the closed API. Should be extensible. Standards should be designed in a way that new developments or changes in the market can be rapidly absorbed and incorporated. Interoperable is a really big one. That standard will allow different systems to work collaboratively. So that basically saying your lighting system is compatible to work with multiple software applications. So that being, whether it's an Autodesk, for this company in my head, Autodesk one or a SketchUp one, those kind of things, where you can just plug and play. You can export your own model and take it into SketchUp. That kind of flexibility in use. And the last one, in my opinion, is very big, is security. So an IOL system should benefit from the IT security technologies currently used by the market. However, ease of use for users, protection of data, and the integrity of the system need to be the foundation of the network security, which it should be built upon. So, as I mentioned earlier, Europe and China are ahead of us in this. They're already creating an IOL standard, and so this is kind of what they have. They have an application layer versus an infrastructure. so, well, I guess, so basically, for us, we're more of a, we have these two separate, whereas they're thinking about putting them in consideration together. Mostly this is because we're really focused on retrofits. It's kind of a big market in our industry as far as energy efficiency is concerned, is just retrofitting a building, bringing it up to speed. There's also quite a bit of a gap in, meeting that demand for the industry. And so that's kind of why I think they're a little bit segregated in this instance, whereas the OpenAIS, they've kind of considered them as partners. One will affect the other. So Internet of Lighting, over the pros and cons, energy efficiency being one of them, building system integration, BAS, introduction of smart services, more wide-ranging and frequent. Some examples would be temperature and light control or geolocation improvement. So if you notice, well, you probably haven't noticed this in a while because of the COVID, but when you used to use Google Maps and go out into the world, you noticed if you walk into a building such as a mall, it becomes entirely inaccurate. You don't rely on it all. You go to the mall kiosk, or you already know where you want to go. One thing that could improve for that is when you walk into the building, your phone switches to the actual lighting wireless network to tell you where you are. And so that could be useful in, basically replacing the mall kiosk or directory. And Google Maps can actually get you all the way from A all the way to B. Post-occupancy comfort evaluations, being able to have feedback given on lighting performance, as well as efficacy or preference, scheduling, operations, and efficiency. Some of the cons is it's just new and it's different to the lighting infrastructure that we've pretty much established for a really long time. So there's going to be some market pushbacks, in particular from building occupants. There's going to be new maintenance requirements, as I talked about earlier, with IT. Privacy concerns, that's definitely a big one, and especially in today's day and age of information sharing and smart devices, as well as increased security risk. So energy efficiency. Systems can calculate the level of illumination required for a different task of the user, with the advantage to calculate the power consumption in real time. However, each independent light can be reprogrammed to respond to the desires of people and situations throughout the day. Such communication can be done instantaneously via Dolly Ethernet, Wi-Fi, Zigbee, or Bluetooth. A General Services Administration study indicated that the typical office worker is away from their desk half the time. So if this vacancy can be captured, then energy savings can be further maximized. So basically, we're going to dim or turn off the light, as well as, if we see their computer is on or there's desk heater or something like that, you can also tell that to turn off to save energy. Here's kind of an overview of the current technologies we use for network communication. I'm not going to go into in great detail to bore you. It should be aware, though, that while this can coexist with your additional infrastructure, you need to keep in mind the levels of data you're transmitting, because you don't want to basically overload the system, so to speak, make it think itself too much that it basically has to shut down and restart, which would not be good. As well as, any latency issues. We don't want that happening. That's why the uninterrupted power feature over PoE is very viable. Because if there could be a latency issue, we could have the lights flicker. And we don't want them doing it at a frequency that would potentially cause someone harm, such as a seizure. So that's very important to manage that. So some of the pros, you see an upfront cost and reduction, assuming wireless infrastructure is being used because of the new, as well as, addition to the new lighting infrastructure or PoE, if that's being utilized. Now, there's kind of a range of savings you can get. 10 to 20% can be gained through lighting controls. The reason for that is how extreme are you setting the control features? If you're giving no one control and you're implementing, a standard typical control system that you've designed to be, all the lights are going to be operating at 85% capacity. They're going to have this color temperature. You're going to have these options to dim or switch off. This area is going to, reduce its kilowatt hour or its lumen output based off of available daylight. And, so that's going to get you within that range depending on how you stack and layer those control variables. You're going to see a reduction in the operation and maintenance expenses, particularly if you use PoE. Like I said, we're changing the actual LED fixture itself, removing that latency heat sink, which is the biggest drawback on its lifespan. And you should see a return on investment in a couple of years, typically under 5. The other pro is building system integration. So interoperability standards allow flexible and communication with other building systems such as BIS, smart grids, or cloud services. Enables a transition from command-oriented lighting to service-oriented lighting control. That one was not as relevant about a year and a half ago, but now it is. This being with that huge shift we're seeing of people still working from home, taking shifts, so to speak, to come in and work in the office. It's not at 100% capacity. So that's where the service-oriented lighting control comes into play, which is only on demand and where you need it. And it's very flexible and can be reprogrammed. So if you want to change your open office layout or et cetera, if you're doing a retrofit, it makes it a lot easier. An example, sharing occupancy data collected with BAS for HVAC optimization, as well as increasing the potential for increasing data points for smart thermostats that would lead to more efficient cooling or heating loads. Post-occupancy comfort evaluations. So we can employ algorithms for smart lighting that are capable of tuning color reproduction in real time, influence human circadian rhythms, and other non-visual functions. Those being attention span, hormone secretion, body temperature, and sleep. In addition to human comfort evaluation, other fields can and are benefiting from a complete control over the spectrum of light output from luminaires, i.e. horticulture, museums, performing arts, and libraries. So one of the applications that it could be used for in museums is, the flexibility of setting up different exhibits for viewing and lighting, being able to reprogram the lights like that, as well as collect data on the occupants in the building. So some of the cons, it being new and different, the market will be confronted on several fronts, from commissioners and facility managers to manufacturers and codes / standards. Not only increases the automation of tasks within the industry, but in some instances, for example, designers, installers, and suppliers will be required to expand their knowledge base and expertise. And that actually also includes building occupants. They also need to, in some instances, be familiarized and brought up to speed with this new technology and how it's going to work and the flexibilities and what are the interactions they could be having with it. New maintenance required. Dedicated lighting network to an IT network raises several issues or questions, such as reliability, guaranteed performance of the system. So we've all had it. I've experienced several times since working from home where my internet just goes out and I just can't connect or work on a lot of things if I don't have it on the desktop. So that'd be really frustrating if that happened to your light. So using a separate network for lighting or ensure a minimum bandwidth available for lighting purposes. Limiting network failures by use of fallback controls or redundant network components and connections to circumvent failing parts. As I mentioned earlier, when an issue with the light or fixture occurs, the occupant usually calls mains or facilities to fix the light. However, when the fixture's hardware and software uses IOL, they require a different skill set, such as network configuration. So who do you call for maintenance issues? Now, this could be one of the actual benefits of a closed API, where typically a closed API, they have a dedicated workflow methodology built in to basically address this issue. So all you have to do is like, hey, this light's not working, and you push the button and it goes and sends the actual code or request to someone to say, hey, you need to fix this light. Or the system will be like, this light's not operating, we're gonna reboot this one. Privacy concerns. While data collection and analytics enabled by IoT can be beneficial, however, collecting information on individual users, such as occupancy pattern, motion tracking, or creating a usage profile can lead to privacy concerns. One of the big ones on that right now is so using LLLCs or IOL in a warehouse for asset tracking and management of, say, your goods, where they're stored, where they're moving, so you can quickly locate something, right? You can also take that application and apply it to a hospital. Say you need to find a doctor or a nurse or a wheelchair or et cetera. You can do that. You can go and find that person. You can take it too far and say you're going to track your workers in the warehouse and, see their route patterns, their occupancy patterns, but go further into the data and say, okay, how long did you spend on break? How long did it take you to go get and do that task? It should take you, we want to increase the efficiency of that. So basically, the questions to consider are, what information do you want to know and why do you want to know it? So do you want to know how many people are in the conference room or who is in the conference room? I subscribe that it should be the former, not the latter. I just want to know how many people in the conference room. I don't want to know who it is. Increased security risk. For the IOL, the system becomes vulnerable to attacks when connected to the internet. So yeah, it's great. Every light fixture now is smart and is exchanging data and is acting as a doorway for all the building occupants. However, you've just created a lot of doorways that other people know how to open as well. So having a system secure while operating is a core issue that needs to be addressed continually by either the building owner or designer. So that's going to be a constant thing that should be considered with maintenance of the system, is the security and integrity of the system as well. So updating security provisions are needed excessively. Development of methods to detect security violations or attempted intrusions to protect sensitive information, but also keep the building systems operating as intended. With the current state of technology and development, it's impossible to say for sure that one building type will benefit more than another, because all buildings would see an immediate cost and reduction on improved energy efficiency. That's just how versatile and flexible this technology can be. Once the technology and development becomes standardized, we can then evaluate the economic opportunities, such as rate of return, levels of complexity within the system, and creating benchmarks for occupant comfort. So in conclusion, the transition towards IoT enables the using and sharing of the network infrastructure in the building rather than a dedicated network for each building service. The value of IoT for lighting companies comes from the data generation using sensors and light fixtures so as to create smart services that consumers and building managers find indispensable. So we're changing the lumen output of a fixture above your cubicle via your phone app or web page. As well as in addition, you can fill out a survey saying, what you feel the air quality is, how comfortable you are in the space, whether there's glare. Multitude of issues can be evaluated post-occupancy with this technology. reduction in lighting systems initial cost, as well as development of a software program that commissions or calibrates lights on an annual basis. So lighting appliances in the IoT ecosystem converge in several areas: health and wellness via circadian rhythm, advanced control systems and strategies, optical communications, and yes, this is true. This is an actual term, Wi-Fi, which is basically Wi-Fi via your light fixture. I don't know why someone felt the need to change it, but that is a thing, as well as location services. A smartphone is no longer just a phone, but a fully integrated mobile device and communication device. Future Luminaires are on this path where they will integrate control strategies, sensors, and connectivity into a single package, i.e. LLLCs has taken a step in this direction. I will say though, this is kind of where I have met the most pushback from building occupants, is when we start to jump towards this. One building I worked on in particular to help them with their LLCs programming the control strategies of it, because the building owner decided to remove most of the light switches in the building. There's still light switches, but mostly in big dedicated areas like the theater space and the galleries. But the individual studios no longer had light switches, and that really upset a couple people. So just keep that in mind with this, is that sometimes it has to be explained or demonstrated for people to kind of like, get the light bulb to click and be like, oh, okay. And so with that, we're going to wrap this up. We'll start taking questions if you have any, as well as I would like to announce that LLCs are coming to the IDL. We're dealing with some red tape right now, whether we can get it done before the end of the year or if we have to wait till January. But this is going to happen. So we'll be happy to. It's intended to be a demonstration showroom. However, COVID kind of threw those plans for a loop right now. So depending on how next year goes, we'll be happy to invite you into the lab and show you. But if we're not allowed to do that, we'll be making several demonstration videos for it, walking through the technology. Oh, and I should probably, if you could also fill out the poll I just launched, it'd be greatly appreciated. And here's kind of what that looks like as far as the phone becoming your light switch. Okay, I'll just hang out until polling is complete. If you have any questions, feel free to unmute yourself or type it in the chat. If not, thank you for attending today's lecture. Hope you have happy holidays and hope you stay safe. Thank you.